Let's say Ahmed is making orange juice. He knows that to make exactly 1 cup, he needs 2 oranges. But today, his brother wants some too, so Ahmed needs to make 2 cups. Without thinking too hard, we know he needs 4 oranges. To double the juice, he just has to double the fruit. You already know how to do this. We naturally scale recipes, time, and distances in our heads long before we ever see the formal math rules written down on a chalkboard. In mathematics, when 2 ratios are exactly equal, we call that a proportion. Our juice recipe looks like this as numbers. 2/1 equals 4/2. And the formal algebra looks like this. A to B equals C to D. To work with these equations, we need a few terms. We call the outside variables, A and D, the extremes, and the inner variables, B and C, are called the means. Correctly identifying these positions is the first step toward the cross-product calculation we will use to navigate the rest of this unit. Cross multiplication means multiplying across an intersecting path gives the same number. Testing 4/7 and 12/21. 4 times 21 is 84. 7 times 12 is 84. The products match. But with 6/10 and 10/25, 6 times 25 is 150, 10 times 10 is 100. They're not equal. Cross-multiplying acts as a mathematical lie detector. It immediately reveals whether a relationship is perfectly scaled or completely broken. Once we know the rule always works, we can use it to find pieces of information that are missing. Here we have 12/16 equals 21 over an unknown variable, x. We set up our equation to cross-multiply, just like before. 12 times x equals 16 times 21, which is 336. Divide both sides by 12, and we find that x equals 28. Proportions are predictive tools that let us fill in the blank gaps in any dataset. Let's try this with a real-world problem. A car covers 320 kilometers in 4 hours. How much time will it take to cover 480 kilometers at the exact same rate? Pause the video for just a second and try setting up the 2 ratios yourself on a piece of paper. To set this up correctly, match the physical units. If kilometers stay on top initially, they stay on top in the second ratio. Same for hours on the bottom. Cross-multiply to get 320x equals 1920. Divide by 320 to get 6 hours. Knowing all the algebraic tricks is entirely useless if your physical units aren't aligned perfectly before you do the math. Numbers in equations are one way to solve these problems, but we can also map them visually. This graph shows distance over time. If a runner covers 6 meters in 1 second and 12 meters in 2 seconds, we can plot those points and draw a line connecting them. To pass the graphical test for a proportion, the line must do 2 things. It has to be perfectly straight, and it must start exactly at 0, 0, the origin. But look at this second line. Imagine a taxi ride that charges a $10 starting fee before the car even moves. The rate of the fare increases steadily, so the line is straight. But because of that starting fee, it hits the axis at 10, not 0. Therefore, it is not a true proportion. Plotting your data exposes false proportions instantly. It proves that just because a rate is constant doesn't mean it is proportional. We've covered the 3 main ways to identify and solve proportions. First, they are exactly equal ratios. Second, they always pass the cross-multiplication test. And third, on a graph, they form a perfectly straight line through the origin. Take a quick screenshot of this checklist.